We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello and namaskar to all the viewers. Today I am going to share how to design the WRC beam. Before I start the design of WRC beam, let me tell you what does the design of beam means. Design of beam means load is given, properties of the material used are given. We need to find the dimensions of the beam as well as the reinforcement detail. In some cases, dimensions of the beam are also given. We need to find the reinforcement detail, right? So in our example, dimensions of the beam are given, factor moment is given, properties of the material M20 Fe415 are given. We need to find the reinforcement detail. See, design for tensile and compression reinforcement for a RCC beam 250 mm wide, means width of the beam is given 250 mm, and 500 mm deep. Its overall depth 500 mm is given. M20 Fe415. Effective covers on both sides are 50 mm. It means small e means effective cover in tensile zone is 50 mm, and the D dash effective cover in compression zone is also given 50 mm. The factored moment means we denote this as mu. It is given 300 kilonewton into meter. So what does this factor moment 300 kilonewton into meter means? Means when beam is subjected to load and due to that load, the moment developed is 300 kilonewton into meter, and considering the factor of safety, this 300 kilonewton into meter is given. So first, what we need to find, we need to find the limiting moment of resistance of singly RC balanced section. As we know that the WRC beam is the combination of singly RC balanced section and the auxiliary section. So first we need to find that how much moment a singly RC balanced section can carry. So for Fe415, we know the mu lim is equal to 0.138 FCK BD square. 20 B is 250, and the small d, capital D is 500. The small d is 500 minus 50, means capital D minus small e. So it comes 450 mm. 450 square. 0.138 into 20 into 250 into 450 square. So it comes 139.73 into 10⁻⁶ Newton into mm is equal to 139.73 kilonewton into meter. See, now what happens here? The moment applied is 300 kilonewton into meter, and the limiting moment of resistance is 139.73 kilonewton into meter. It means we cannot design the beam as a singly RC beam. Why? Because singly RC beams, the balance sections, the maximum moment carrying capacity is 139.73 and the moment is acting as 300 kilonewton into meter. So mu is greater than mu lim. Therefore, design the beam as WRC beam. So next step is how much extra moment is acting here. So we denote this as mu2 and the mu2 is mu minus mu lim is equal to mu is 300 and the mu lim 139.73. So we get 160.27 kilonewton into meter. So in this way, in WRC beam, for this moment 139.73, we will design the beam as singly RC balance section, and for this moment we will provide the reinforcement in tension zone, and we will tell this steel reinforcement as AST1, and for this moment 160.27 kilonewton into meter. This means this is that auxiliary section. This is all about that auxiliary section, and for this moment we will provide the reinforcement in compression zone as well as in tension zone. So in compression zone we will denote this as ASC, and in tension zone we will denote this as AST2. So in design of WRC beam, we need to find the AST1, AST2 and the ASC. So first let's find ASC. So to find ASC, first we need to find the FSC, stress in steel in compression zone, right? So we have two options to find the FSC, using handbook as well as using IS 456. So we will use both the methods. First, using handbook. For that, we need to find the d dash upon d. D dash is given 50 and the small d is 450 is equal to 50 upon 450. So it comes 0.11. Page number 13. From page number 13, table F, we get okay. For FE 415, the value is given in table 5. For the value of d dash upon d is 0.10 and 0.50, and our d dash upon d value is 0.11. So you can take the value of 0.10 also, and you can also take the value of 0.50. But for getting the exact value, we need to interpolate this, right? So first, we do the interpolation to get the exact value of FSC. So we know that in handbook 4.15, it is given FSC value is 342, and for 0.10 it is given 353. All right. The question arises in your mind, why I have taken 0.15 and 0.10 value? Because this 0.11 is the value in between these two values. That's why I have taken the 0.15 and 0.10. This is plus, therefore minus and minus. 0.15 minus 0.10 is 0.05, and 342 minus 353 is equal to minus 11. So what does that mean? If in d dash upon d value the difference is 0.05, the difference in FSC will come minus 11. But we don't need the difference of 0.05. Our interest is 0.11 value, right? So we just take the reference for 0.10 value. It means 0.11 minus 0.10. For the difference of 0.11 minus 0.10 is equal to how much? Is equal to 0.11 minus 0.10 into minus 11 upon 0.05. 0.11 minus 0.10 into minus 11 divided by 0.05. So we get minus 2.2. So what does that mean? If in the d dash upon d value the difference is 0.11 minus 0.10, it means 0.01. So what will be the value? What will be the difference in FSC value? So the FSC value comes minus 2.2, and we have taken the reference for 0.10 value, and the FSC value of 0.10 is what? 353. So finally we get FSC is equal to 353 plus the difference come. So 353 plus minus 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 2.2, we get 350.8 Newton per mm square. So in this way, doing the interpolation, we get the FSC value 350.8 Newton per mm square. Now let us find FSC value using IS 456. We know that for finding the FSC value using IS 456, first of all we need to find the XU max. So for FE 415, XU max equal to 0.48D. So from where we have taken this? From page number 70. Is equal to 0.48 into small d is given 450. Point 48 into 450, 216 mm. Once we find the XU max, we need to find the strain, and the equation of strain is given in IS 456 page number 96. And the equation of strain is 0.0035 XU max minus D dash upon XU max is equal to XU max is 216 minus 50 upon 216 is equal to so it comes 2.689 into 10 to minus 3. It means 0.00268. So this is the strain value, right? Now, with respect to this strain value, we need to find the stress from IS 456, page number 70, graph 23.8, right? So in graph, the value of strain 0.003 is given. So here 0.0027, so it is slightly near than the point 0.003. Just draw the parallel line, and when it intersects this Fy upon 1.15 value, you will get approximately FSC is equal to right here. FSC value from page number 70 graph 23A, FSC is equal to 0.84 FY is equal to, we get it comes 348.6 Newton per mm square. See, using handbook, the value of FSC has come 350.8 Newton per mm square, and using IS 456, the value has come 348.6 Newton per mm square. The difference is not much, so you can use either this value or either this value, right? So now, once we find the FSC value, we know that mu2 is equal to what? C2Z2, right? In the stress strain diagram of WRC beam and in for auxiliary section, what we have shown that C2 force and that T2 force, the vertical distance between C2 and T2 is Z2. And if you take the moment at the bottom of the reinforcement, right? So the mu2 means mu2 is equal to what? C2 into Z2. And the C2 is equal to, we know, FSC into ASC, and the Z2 is D minus D dash, mu2. And we have the value of mu2, 160.27 into 10⁻⁶. Why I have written 10⁻⁶? Because this value is kilonewton into meter, and the FSC value is in Newton per mm square. That's why I have converted kilonewton into meter in Newton into mm. Kilonewton to Newton 10⁻�3 and meter to mm again 10⁻�3. So total 10⁻⁶. FSC we have 348.6 into ASC D. Small d we have 450 minus 50. That's why 160.27 into 10⁻⁶ upon 340.6, 450 minus 50 is equal to ASC. That's why we get ASC is equal to 160.27 into 10⁻⁶ divided by 348.6 into 450 minus 50, you can say 400. 1149.38 mm square. So, what does the 11.49.38 mm square means? It means to resist this extra 160.27 kilonewton into meter, we have to provide the reinforcement in compression zone having minimum area 1149.38 mm square. So we have already provided the reinforcement required in compression zone for that auxiliary section. Now our target is to find AST1, right? So what is AST1? AST1 is the area required to resist that mu limb moment, and the value of mu limb is 139.73 mu limb. Now, how we find the AST1? For finding AST1, we need to find PT limb. So PT limb is, equation is, you have to memorize this. PT limb is equal to 41.61 XU max by D FCK upon Fy. And for Fe415, we have XU max by D value is 0.48, FCK 20 and 415. is equal to 41.60 is 0.96%. So here, question may arise in your mind why I have written PT limb instead of PT only, right? So what we are going to find in this portion AST1, and the AST1 is reinforcement required for singly RC balanced section. It means a singly RC beam, how much it can carry the maximum moment, and for carrying that maximum moment, we need to find the maximum percentage of steel, means limiting percentage of steel. That's why we need to find the PT limb, and the AST1 equal to PT limb BD upon 100. PT limb is 0.96, B is 250, and the small d is 450 divided by 100. So in this way, we get AST1. $1080. So what does this AST1 1080 mm square means? It means to resist that 139.73 mu limb moment, right? We need to provide the minimum reinforcement having area 1080 mm square. Now, the next we need to find is AST2. Now, what is AST2? For that auxiliary section, and for auxiliary section, we are using the moment 160.27 kilonewton into meter. For that, how much area of steel is required in tension zone? And for AST2, in IS 456, page number 96, they have already given the equation. So from that, I write the AST2 equal to ASC FSC upon 0.87 FY. IS 456, page number 96 is given. Is equal to ASC. We have ASC 1149.38 into FSC. We have 348.6 upon 0.87 into F5 is 415. So in this way, we get 1149.38 to 348.6 divided by 7 into 415. So we get 1109.75 mm square. So area required for tensile reinforcement in tension zone to resist that moment, additional moment 160.27 is 1109.75 mm square. Finally, AST equal to AST1 plus AST2 is equal to AST1 we have 1080 plus AST2 1109.75. So it comes 2189.75 mm square. This is the AST. Now finally, we need to provide the reinforcement for ASC and this AST. So here you can use handbook and you can directly provide using the simple mathematical calculation. So first we use the handbook. Using handbook, how to provide reinforcement. Let's see. First, for ASC 1149.38 mm square. So for providing reinforcement in handbook, table number 95, in that table, horizontal line is given diameter and the vertical line is given number of bars. And in this area, they have given area in centimeter square. So our area is in mm square. So let's convert this first in centimeter. So what it happens, 11.49 centimeters square, right? So in beam, generally we provide 3 or 4 numbers. So it depends. What is the width of the beam? Here, width of the beam is 250 mm. So if we provide 4 or 5 mm, it may not be satisfy the spacing criteria. So in this way, so in this, I mean, in the case of 250 mm or 200 mm wide beam, you provide 2 or 3 numbers. So we provide 3 numbers. So in this column, numbers of bars, just look at the horizontal line in number of 3 row. So you get in 3 number row, select the area having more than 11.49 centimeter square. So it is 14.72. 14.72 centimeter square, and that is 3 number 25 mm dia. So in this way, what we provide 3 number 25 dia having ASC 14.72 centimeter square equal to 1472 centimeter square. See, area required was 1149 mm square. But what we have provided 1472 mm square. Now for AST is 2189.75 mm square is equal to 21.89 centimeter square. Now the same way, first look at in the column of number of bar. So in 3 number, if we look 1121.89, so we get 3 number 32 mm dia having AST 2412 centimeter square equal to 212412 mm square. See, area required was 2189 mm square and we have provided 2412 mm square. Select the area which is greater than the required area. So in this way, we can provide the reinforcement using the handbook. Now, in the absence of handbook, how we can provide the reinforcement? Let's see that first. See, for ASC, equal to 1149.39 mm square, right? What is the equation of area? Area is equal to number into pi by 4 d square. So ASC number into pi by 4 d square. Here area required is 1149. So you just fix the number, either 3, either 2 or either 4. It's up to us. Here width of the beam is 250. So if we provide the 4 number, I think it may not be satisfied the spacing criteria. So let's try first 3 number into pi by 4 dash square 1149.38 into 4 upon 3 pi equal to this dash square. And under root answer is equal to, we get 5 equal to 22.09 mm. So we need to take what? Minimum diameter required is 22.09 mm. So take more than that diameter. After 22 mm dia, it comes directly 25, 23 mm and 24 mm diameter of bar is not available. So directly take 25 mm dia. That's why provide 3 number 25 mm dia having ASCC. Using handbook, we have also provided 3 number 25 mm dia and a 1472 mm square. Similarly, for AST 2189.75 mm square, the equation will be number into pi by 4 dia square. Area is 2189.75. Just fix the number. Pi by 4 dia square. 1121.75 into 4 upon 3 pi equal to dia square. Therefore, diameter 2189.75 into 4 divided by 3 into pi. Answer, we get 30.49 mm, which is nearly equal to 32 mm dia. Why? Because 31 mm dia is not available. See, here using handbook, we have also provided 3 number 32 mm dia. So provide 3 number 32 dia having AST 2412 mm square. So either you can use handbook or you can use this simple mathematical calculation. And finally, just show the cross section, draw the cross section and show all the details that you have designed. This is width of the beam 250 mm. We have provided 3 numbers of AST 3 number 32 dia, and in compression zone we have provided 3 number 25 mm dia ASC. This is the neutral axis. Effective depth is 450 mm. This is E50 mm and D dash is also 50 mm. Cross section of beam. So in this way, we can design the doubly RC beam, right? So today, what we have done, we have designed the WRC beam. In WRC beam, we have provided the area of reinforcement in tension zone as well as in compression zone, right? After providing the reinforcement, the next step is to check all these criteria as per IS 456. It means whatever reinforcement we have provided, it is appropriate or not as per IS 456, appropriate or not in the form of spacing, minimum spacing criteria and maximum spacing criteria, as well as what IS 456 has recommended that in beam, minimum percentage of steel with respect to its cross-sectional area should be there, and as well as maximum percentage of steel criteria is also there. So in next lecture, we will check all those things using the data of this example. Now today, with this, I conclude the session. Thank you.